Hey there, everyone, and welcome to today's Techbytes talk. I'm Niklas, and I'm truly honored to today introduce Eric Brewer for a talk at Techbytes. Eric is a Professor Emeritus of Computer Science from the University of California, Berkeley, and today a Vice President of Infrastructure at Google. He also historically did a few small projects like launching the first websites for the US government and launching a company called Atomic back in the days. I guess he's probably most well known for the creator of the CAP theorem. As someone who's a bit of a geek around distributed systems, I spent too much time thinking about that. He also wrote the CEDA paper, which informed, among other things, the way Netty, something we use very heavily, does thread pooling. There's also a small Spotify connection here. Eric gave the talk launching Kubernetes just the day after we launched Helios at the very same conference, maybe the worst timed thing we've done so far. He's also had a long involvement in the open source space, and which will be part of the topic for today's talk on security in open source. This talk is recorded, and we will publish the recording. We might or might not publish the Q&A. We'll have to see about that afterwards. If you have questions, please use the Techbytes code on Slido. You should find the link in your invite as well. And if you have any questions on Techbytes, feel free to reach out to the Techbytes team on the Techbytes Slack channel. And with that, welcome, Eric.
Thank you so much. It's an honor to be here, virtually even. And sorry I can't see you in person for all of us. But today's talk is going to be what I call the open source supply chain risk. Looking for the slides. There we go. Next slide. So a foundation of open source is this idea that all bugs are shallow, because so many people are looking at the code. If there's a bug, someone will find it easily. And that's also the basis of security for open source. Many eyes will find the problems and fix them. Next bullet. The problem is that it's not actually true, right? The reality is that popular things like Kubernetes have lots of eyes, but there are many, many packages with no eyes on them. And those packages are still in use despite no active development. And that means anyone can attack those packages, and you may use them directly or indirectly without realizing it. On top of that, there's been increase in incentives. Now that everyone is using imported software and open source, we've seen attacks around Bitcoin, around credit cards. I'll go through those examples in a minute. But the bottom line is the many eyes idea is not really true if you're a malicious adversary. Next slide. So just to be clear, what's the threat model I'm worried about? And we have seen this, as I'll show you in a few examples. The threat model is an attacker puts some malicious code in a widely used package. Hundreds of thousands of other projects use that package. They use it in their websites or their infrastructure software. If you're the attacker, what you want to do is you want to pick a package that's popular, but not under active maintenance, right? That's not really has a bunch of eyes on it. And you probably want to obscure your changes, so if someone does look, because all this is done in the public, they don't really notice what's going on. And so you might use multiple commits where individually each commit is not so bad. You might actually even include an image, which is actually in reality encrypted code and not an image, and you can decrypt it and use that code in your package later. Once you've installed malicious code in a package, then the rest is pretty easy. The package gets built and stored on a trusted site. Could be something like npm site. It could be, any popular site that stores repos. I don't want to pick on repo sites, but any of them. And then, to make matters worse, the package will get signed, right? So now we know it's the signed package from the right site. We got it under SSL. What does that mean? Well, all that means is the package was built from source code. It doesn't mean that the package is free from malicious code. So the signature is not all that helpful. Finally, importers bring in the malicious code and trust it, and that can be direct or indirect. In fact, I got into this looking at Kubernetes and how many things we import, which is thousands of packages. And when you import thousands of packages, it's hard to make sure that all of them are trustworthy, right? And that's true for lots of other systems, not just Kubernetes. Next slide. So example number one is from Ticketmaster. They included some JavaScript code, actually from a paid supplier. This was a group that was going to do some tracking of clicks on their website. That code in turn included an open source package that had malicious code in it. And the attack was a credit card skimming attack, which means basically it's looking at form submissions, kind of think of the on submit form submission, and it copies the form data to a remote site. Now, it's pretty much copying lots of form data, but some of that form data is credit card details, and presumably millions of credit cards were copied this way. And Ticketmaster kind of got the most notoriety, but frankly, that's because they discovered it, right? Many other sites were also importing the same package with the same attack and just didn't know, right? So to back up a little bit, this is Ticketmaster not even using open source directly. It's using a paid supplier who's then using packages which then include packages that are malicious. Next slide. Another one that's interesting was this eventstream.js, which is a small JavaScript package that had a maintainer, and it was modified to steal Bitcoins in a very narrow way. This was an attack on Copay in particular in their wallet. And so presumably what the attacker did is look at what things Copay imports, find the one that was least watched, asked to take it over. So he became the maintainer. And then he was able, as a maintainer, to insert the malicious code in multiple steps, all in the open, right? It's not doing anything in secret. It's just that no one's looking, so no one noticed. And it's worth pointing out that the account that owns these things doesn't have to be tied to a real person, right? There's lots of use of anonymity in open source, and I think most of the time that's appropriate. We'll come back to that later, but it does beg the question, when is it okay to be anonymous when you're working in open source? The quote at the bottom is from the previous maintainer. He just said, he wanted to maintain the module, sounded great, basically. The original author doesn't even use the thing anymore and had no reason to worry about it being taken over in a malicious way. Next slide. So Google's been using open source for a long time and created thousands of packages. What do? Well, we have a partially decent solution, but only partially. So we make a local copy of all the code we use. And in particular, there's a rule that says you're not allowed to use open source directly from a public repo. You have to basically copy it in and use the private repo. And that's a good idea for lots of reasons. The main thing it gives you is it decouples the version you're using from the latest version, which means at least you'll have some time to discover any bad changes before you use them. It also means you can keep your own private patches. So if you discover something that's a security problem for you, you might patch it locally immediately and then worry about getting it upstream on a more reasonable timeline. So you'd have to have private repos. I think that's an important step regardless. Each private repo has an owner, and the owner is supposed to take responsibility for what's in that repo. And so this started with things like license restrictions. So, we don't want to import things whose licenses we don't like. So you need to make sure that the licensing restrictions are okay. You're supposed to track security vulnerabilities, in particular the known ones. So if you find out about a security vulnerability in the thing you imported, you're supposed to, make updates and fix it. And more generally, you need to review incoming changes. So these are not static things. The public version changes frequently. You need to, be periodically taking those updates and reviewing them. So that's how it's supposed to work. The problem is, next slide. The problem is they're not really enough. And even the basic thing, like how do you make sure that all open source code is coming from a private repo and not from somewhere else? Someone's building on a third-party site, or it's a included library from somewhere else, or someone's building on their laptop. you don't know where they got the source code from in general, right? So you have to first enforce that. Obviously, it's only going to help with known vulnerabilities. That does not help at all, particularly with malicious updates. And if someone is trying to insert a malicious update, you're not going to get any warning about that, right? The community doesn't know about it and won't help you. Some packages are hard to update. This is not a security problem per se, but in general in open source, if you have an imported package, you want to do a big update, it may affect the importers of your package, and you need to go fix them also. And so sometimes we get stuck where packages are just old because no one can do the update to the 10,000 places that need to be changed. But that's not really what I'm worried about. What I'm worried about is this red bullet, which is, it is actually unrealistic to review all the updates in detail, right? Some of these packages have, might have 1,000 changes in a month. That's a bit of an exaggeration, but certainly that if you are updating it only periodically, there's a lot of things to review. And the question is, would you catch a malicious hidden update if you were looking, right? What gets through this review process? And the way to think about this is really that it's kind of an unfair request on the owner. If you have a lightly used package, you probably can review all the updates. If you have a popular package, something like Angular that's big and complicated, I don't see how you could possibly keep up with all of the changes. It doesn't mean bad things are getting through, but it means that you don't really know. And finally, when should you not take an update? Right? Do you really want to be in the bleeding edge of the module, or would you rather wait and see if there's problems in a module, let someone else find them? And that's the discussion we're still having. Right? Historically, we wanted updates as early as possible because you want to get the latest security patches. But if you flip it around and say, do you want the latest malicious attacks? You would say, no, I'd rather wait and take the source code a little later. Maybe Ticketmaster will find the problem for me and I don't have to experience it directly because I hadn't switched that version yet. So not clear what the policy should be, but it's more complicated than it used to be. Next slide. So this is a very hard problem to fix, and it's kind of why I'm giving this talk. In fact, you'll see me give versions of this talk probably quite a bit in the next year or so, because we need public awareness and we need to decide what risks do we want to take as an industry, right? And in fact, a lot of the processes involved right now are very manual, which is the reason that they don't scale. So we're going to need some new infrastructure that enables automation. Talk about that only abstractly, frankly, because we're not there yet. And then we need to figure out what standards or processes do we want for importing and using code. And one thing to think about is, we don't do this today, but we ought to separate, I want to import a package from my home web server, right? I don't really care what you use for your home web server. If it's insecure, I won't be happy, but it doesn't affect all that many people. Versus something that's going to be used in the electrical grid or core infrastructure like Kubernetes that's then in turn running a whole bunch of other stuff. The standards for import for something that's critical need to be much higher, which means we need to separate what do we think of as critical and what do we think of as not critical. We don't have that separation today. Next slide. So on the awareness front, this is something that we're working on. This is not public, but I'm going to talk about it anyway, which is ideally you would like to have a site that shows you the dependencies of all the things you're using. And there's a little bit of this in GitHub. There's a little bit of this in certain communities like NPM Audit. But in general, you'd like to understand what things you're depending on, and in particular, what known problems those things have recursively, right? So you might get notification about changes in things you're using directly, but you don't typically get notifications of things that you're using indirectly, right? Because the owners of those things would have to actually understand that and pass it on in some sense, and that step is missing. So you actually have more risk from indirect inclusions than from direct inclusions, which at least you might get warnings about. We also have no way to know how risky software is. Like when you're importing something, how can you tell if it's high risk or low risk? And what would you use to make that decision? I'll talk about that more in a minute. And finally, if we had such a site that could really give you good estimates of risk and dependencies recursively, it also would be play an educational role of, thinking about how many things you include and why. One of the things included in those past examples was a millisecond converter, right, from seconds to milliseconds. So why would you import something that converts from milliseconds to seconds, right? It's a multiply command. And the answer is because it's so easy to import stuff, and maybe it deals with multiple languages, or maybe puts in commas instead of dots or vice versa. But we actually import all kinds of things today that we didn't do 10 years ago. So the granularity has gotten a lot smaller, and we probably have gone too far in that direction. So the awareness is an important part. We're looking at what communities could do, what maybe we could do with foundations. Things like the Linux Foundation have some of this covered, but not very broadly. So that's all in progress, but the public side of this is going to be very important. Next slide. On the automation front, I think the thing to understand is when we track vulnerabilities today, it's essentially in unstructured text. The most famous of which is the CVEs, which no one knows stands for Common Vulnerabilities and Exposures. This is how you report a vulnerability, except that it's reported basically relative to a binary, and you don't actually know which package caused it, which versions are affected, what other things imported that package. None of that is known, right? We just know we have a problem, and it's described in English, essentially. And so one thing we need if we want automation is we have to get away from unstructured text. We have to get to consistent metadata. So for example, we really need to know all the versions that are affected of a given package, right? Typically it's a small range, 5.01 through 5.72, something like that. But that information is not available today. And in fact, the way you get it is you have a human go figure out by hand, testing a bunch of different versions to say, oh, these are the versions that are affected. And that may or may not be accurate, and someone else may or may not review that for accuracy. We, generally speaking, also don't typically have test cases. So is there a test that will tell me whether a given package is affected or not? That's something you would do for regression testing all the time, but there's no real culture around this in open source security yet. Another kind of automation is how would I compute an estimate of risk? I'll get the risk factors in a minute, but since we have to do automation here, we'd really like to figure out, well, just tell me which packages are risky, or which packages are critical, or which packages are used by lots of people and have lots of eyes or have few eyes, right? So we can do things so that when you're going to do your review, you at least are more diligent in the cases that need more review. Right now, it's kind of a flat space. We expect reviews to be done for everything equally, and that's not realistic. So what I'm really talking about here is what tools could we give the community to say, this would be a good place to look for reviews because this seems sketchy. So then what do we need from a given community? Well, because Go comes from Google, we're looking at Go right now. And in fact, Go just did its own package discovery system, which is pretty nice. And it has a dependency model that's interesting, in particular that it lets you have absolute references to dependencies that also have secure hashes. So you really are knowing when you get the thing that you intended. I'll come back to that. That's called provenance. So, we think we can fix Go, but that will only affect that language. You need to do something for every language. We'll talk about package managers in a little bit. Node.js is where those two examples came from previously in the talk, and it's in pretty serious trouble. GitHub just bought the Node company, NPM, and maybe they'll be able to improve its situation. I think that's their intention. But it's JavaScript in particular, because of the language, when you import something, it has a lot of capabilities. And so there's all kinds of JavaScript packages, both for Node and for front end, that are powerful and relatively good attack vectors. Next slide. So risk factors. The purpose here is to understand which things you're importing might be risky and why. And so, again, this is just all brainstorming in some sense, but things that we would expect that would be risky is you see a change in ownership, like someone took over a package that you use and you don't know who this person is, and you've never seen them before, and they've never committed to that package before, right? That's a red flag, right? In general, if you have unknown owners of a package or reviews coming in from unknown reviewers, that's riskier than known reviewers. Maybe you have a committer that's committed for the first time some big change that seems risky, right? Where did that come from? Are they anonymous or not, right? There's lots of things around committing. Are there lots of eyes on it, right? Are all the eyes from one location or one company, right? Diversity of eyes is what you really want. Processes, do they have code review? Many packages don't use code review. Most don't use two-factor authentication. One of the internal rules for Google is that all changes are under strict authentication. So we really know who's making a change, and we always have two people involved. The committer and the reviewer are both under 2FA. So in fact, you can't attack Google's internal code with just one person. But outside, you can attack the open source we use without authentication. Systematic handling of vulnerability reports. Does the package deal with vulnerabilities that are reported to them, right? Do they respond at all? Do they respond quickly? Do they know about them, right? So there's usually a history of vulnerabilities, at least for bigger things, and you can kind of see how they do historically on that. And finally, provenance, which is a word I've used and haven't defined, which is really the signing of the process. So I have some source code. I might have a SHA or a signature, secure hash for say the git commit for that source code. But then what happens to it? Well, it was built by what tools, and it was built into what package, and it included what other packages. There's this kind of a tree of trust that you're using, except that we don't make the tree secure historically. So provenance is really not that your code is absence of malicious code. It's, did the code that you built, is it the code you think it is? Right? That's what provenance is trying to prove, right? Did it come from the source code you think? Did it use the tools you think to build it? Is it stored in a way that's signed and trustworthy? Right? Did you get it over a secure connection so that it wasn't tampered with? Right? So that's something we'll come back to as something you can do now without waiting for the industry. But it only solves the partial problem of you're getting what you think you're getting. It doesn't mean what you're getting is correct. Next slide. One of the places that needs work is package managers, in part because every language has its own package manager and they have different security problems. And none of them are perfect, including Go's. We'll hopefully fix that. And I won't go through these in great detail, but if you say, what do you want an ideal package manager such that you could enable security? Well, the first few are pretty interesting and not that obvious. So one challenge is just having clear versioning number and semantics, like which versions are replaceable for other versions, right? That depends on the versioning scheme and is tied to the package manager. And sometimes those rules are not clear. More interesting one is dependency resolution. When I have multiple dependents, multiple places that are including the same module, there'll be constraints based on those points of inclusion about what they're going to include. So the question is, what version do I actually pick to be included, right? That's called dependency resolution. And the problem we have is that in general, the only way to figure out which version will be installed when multiple are possible is to do the installation, right? But if it's got malicious code, it may even have malicious install hooks, you've just executed them, right? So that's not the way you want to do this. What you really want is first, you'd like good documentation about what is the actual process for dependency resolution, and you'd like that to be a deterministic process. And you might also even like to have a side API, which is show me which version would be installed so that I can actually see if I like that version and if I want to do the install, right? That's really, those aren't separated out today. Vulnerability tracking, direct and indirect, is the obvious one I've already talked about. Clear details on owners and reviewers. Like, assuming a reviewer was using 2FA, it'd be nice to actually record that fact in a signed way. Because down the road, I really feel like anything that's a critical package, you can't have anonymous reviewers and owners because they're not trustworthy by definition. Now, that'll be a cultural change, and again, it won't work for everything. But if you really want to work on critical open source, I would argue you need to do so in the open. Tamper prevention, this is the part of the provenance, but right now, many languages have ways to sign artifacts, like Maven has a way to sign Java artifacts, but they're not the common path, right? They're not easy to use. The same way that 2FA is not easy to use for Git repositories. So in general, there's a UX thing here where we need to make the right secure path be the common path, be the easy to use path. And finally, when you're building packages, you might want to actually keep the details, what we call the attestation, which is here's a signed record of how it was built, where the source code came from, and what imported things it included. Because that's the basis for recursive trust higher up the chain. So lots of things here that really no package manager does well today. They'll do some of these well and some of these less well. But one of my goals is to kind of drive this conversation with all the communities and see if we can kind of move them in this direction. They'll each have their own style. I know we don't need them to be all the same, but we need them to say, here's a minimum standard of what it means to be a secure package manager. Next slide. Likewise, now I want to import a package. What should I be thinking about? Well, the first thing, as I mentioned before, sometimes just use less. If you really need to import the millisecond conversion module, you could write that in a small number of lines of code, and then you would know it was trustworthy, right? So we're probably gone too far in the direction of trust everything, import as much as we can. Ideally, we would know the estimated risk. That's, again, not easy today because no one will calculate a risk factor for you. And the hard part is it's really every update. I think most groups do a pretty good job when they import something at first, taking a look at it and say, does this seem trustworthy? Is this something I want to use? Do I like the community? And you make a relatively well-reasoned decision. Once you've made the decision, though, I don't see most groups being active and checking the future updates. Do I want the new version? What is it depending on? Did it add a whole bunch of new imports that I wasn't using before? Right, when we started Kubernetes, it had like less than 100 imports. Now it has more than 1,000. And that's kind of inevitable in the sense that it's a much broader project. It has lots of different pieces to it. It's going to use more stuff, right? But I would say, other than maybe GKE, almost no groups have actually tracked that evolution and said, are these things we actually want to import or not? And even in the GKE case, it's very hard to do perfectly because it's so much stuff. We'd love to have some automated scanning and analysis. So we do this internally at Google a little bit. We have a project called OSS Fuzz, which is a fuzzer for open source packages. It's looking today at about 250 packages that are used by Chrome. It's in fact built by the Chrome team. But I'd love to see that expanded to 1,000 packages and cover, really ideally down the road, anything that we think is critical. Now, the problem with doing something like fuzzing is it can find lots of problems. Like, I bet collectively we can find 1,000 problems a day in the top 1,000 modules, maybe less. But someone has to fix those things. So it is good, I think, for giving you an estimate of which things are generally done well and lower risk. And the OSS Fuzz team, what they're trying to do is actually send you CLs and say, this is the CL that introduced this bug. We can tell that because we tested the version before and before don't have an after do. So we think this is the CL. We're not claiming to understand why it introduced this bug, but we think if we give you the CL, someone that wrote it can actually easily fix it. They'll understand the context and see why that caused a problem. So I'm hoping that things like that, guided feedback, will actually get these bugs fixed. But we're just in the beginning of that journey. Longer term, of course, how risky a package is depends on how it's used. And so again, a package that's run as root in a situation, it needs more scrutiny than something that's used in your home web server running in user mode, right? And last one, which we don't really have a good idea on, is suppose you knew about a risk in your imported module and you done work to mitigate it, how do higher up the chain groups know that, right? Because they'll know that you're importing something risky. Does that mean they shouldn't trust you? Well, if you've mitigated that case, they should trust you, but now you have to have some way to claim that, at least, if not prove it. And we like this concept of an owner, but it's not that well defined. It's certainly not defined as an industry thing. So, if you're an owner of a package or a maintainer, what do we expect of you? And what's the minimum if you want to be a maintainer of a package that's security critical? Next slide. So broadly speaking, we need to fix this. It is not a Google problem, it's a whole industry problem, and Spotify will have a role, I'm sure. We'll figure out as we go what the best place is. But the real problem is that there's so many things that we need to change, right? I think culture is the hardest one. I think people feel like open source is wonderfully free and unregulated, and we want to keep it unregulated. We actually need to fix this. I'll come back to that point in a minute. But so there's a cultural change in some parts, but then there's a whole bunch of other things, like what do communities do? What do foundations do? What new infrastructure like automated fuzzing and vulnerability routing do we need? What best practices do we want to write down? And both for companies like Spotify importing things and Google, but also you produce open source. So for your things that you're maintainers of that you produce, what are the best practices? And so, within Google, we can do some good things in Go. The GKE team has kind of been pioneering stuff internally, and what can they do locally with private copies, private internal testing. But it's local is good, but it's not enough. Linux Foundation has done some work in this area. GitHub has a security coalition, which I'm an attendee of, that's looking at particular things like vulnerability reporting. So those are good starts, but they're not quite enough. Next slide. So this is my last slide. I'll just say, I kind of view this as an existential threat to open source, in the sense of not that open source would disappear, but if companies feel like they can't trust open source, that will push us back to having mostly proprietary source. And perhaps worse, if governments feel like they can't trust open source, they're going to start regulating it. And I've already seen hints of this in a couple different agencies in a couple different countries. And there's plenty of governments that actually like to fix open source because they don't want that to happen. But certainly, if enough security things happen, regulation will follow. And it may not be well targeted. Regulation doesn't always meet its intended goals perfectly well. So there's some changes needed here, not easy, but super important. So what can you do? Well, again, it's just the beginning of this journey, so more coming, but just think about which packages you're using and why, and more interestingly, why do you trust that package, right? It's one thing if you wrote it internally, maybe it comes from Google and you trust Google, or maybe it comes from someone you've never heard of and you've never met and they're anonymous. And why should you trust that? Well, you might trust it because a million other people use it, or maybe because it has lots of reviewers and committers and has many eyes on it. So there's reasons you might trust it, but I want you to ask yourself why for the things you use. You should definitely use private repos if you don't already. That allows you to decouple what you're using from what's out on public sites. That buys you some time if there's some problems, and it makes it easy to keep security patches quickly and accurately locally. Provenance, how were your artifacts built? Do you know what source code was used specifically to build them, and how do you know? Do you know they were tampered with, and how do you know? You know what compilers and linkers and build tools were used, and why do you trust them? Right? If you haven't seen Ken Thompson's Turing Award speech, it's called On Trusting Trust, and it's exactly about why should you trust the code, and if you trust the code, why should you trust the compiler that compiled the code? And he walks through getting back to the bottom, which is how do you trust anything you didn't write yourself, and how do you build that trust up? So really, another way to frame this talk is we need to build the recursive infrastructure that allows us to start at the bottom and trust things at the top, like Kubernetes, that are very complicated, right? And without that infrastructure, we can't trust any of it, which is where we are today. So, and finally, you can help us fix this. I don't know specifically how yet, but I'm hoping to sort that out in the next several months.